This is the reading for the net ionic equation section of the solutions unit. It's not very long. It does look like it's 4 pages, but lots of it is equations and work. So don't worry about it. When we go through, we're going to talk about different ways of writing out equations. We can have molecular equations, ionic equations, total ionic equations, net ionic equations. It's important to be clear in which ones we're looking for. Here's an example of a molecular equation. Although these are listed as aqueous, it's still a molecular equation because nothing is broken apart. How do you know which ones are aqueous and which ones are solids? In other words, form precipitates. You look at your solubility rules. And when you look at your solubility rules, you're going to see that sodium and chloride are always soluble. Nitrates are always soluble. So that makes sodium nitrate soluble. Chlorides, as I said, were always soluble, except with lead, mercury, and silver. And here we have silver. And so this chemical will be a precipitate. When you look at the total or overall ionic equation, anything that is aqueous will split up into its ions. So sodium chloride turns into the sodium ion and the chloride ion. Silver nitrate turns into the silver ion and the nitrate ion. Again, because sodium nitrate is aqueous, they're going to split up into their ions. And then the solid here is the precipitate, and because it's not aqueous, it's not going to dissolve, it stays as it is. These are double replacement reactions usually. Sometimes they're acid-base reactions. Here we have an acid-base reaction. But again, by looking at the subscripts of the states that these chemicals are in, we can see which ones will dissociate into their ions, which ones as products will stay as ions, and which ones will have changed. Okay? Now there is no precipitate in this reaction because there's no solid, but water was not one of the starting reactants. Carbon dioxide gas is not one of the starting reactants. So these are new things. They're listed by their state, and they need to stay that way. Now, we have another example here. You can pause, take a look at it. Notice we have the coefficients listed. Net ionic equations are when we remove what are called spectator ions. Spectator ions are not involved in the reaction. In other words, they appear on both sides of the arrow exactly the same. In this case, sodium is here and the sodium ion is here. They're exactly the same, and so they get canceled out on each side. The same is going to be true for the nitrate. It appears on both sides of the equation, so it gets crossed out. The net ionic equation is whatever is left over. Okay, now they did switch the silver first. Usually they probably just have it pretty much put the positive ion first. Notice the net ionic equation is made up of whatever the precipitate would have as ions on the reactant side. The rest of this reading is going through examples. Go through it slowly. Make sure you're paying attention to where everything is and what everything gets canceled out. And then there's a summary. The solubility rules are in the slide notes and in that video that I made there. Have a good day.